Okay, in this physics problem we have a gun that's positioned in a horizontal way. It's laying on a table and it will shoot a ball out in a horizontal fashion this way. The ball will start curving down and it will hit the ground. The information that we know is that the ball will leave with the initial velocity of 6.10 meters per second, and it'll come all the way to this point. The height from the ground to the bottom of the ball is 0.950 meters, and where it hits the ground, that will be 0 meters. Now, we also know gravity, negative 9.80 meters per second square. And for just to make it easier for us, we're gonna put our axis of x and y, we're gonna position it not down at the ground, but up here where it started. So this will be my x-axis, and this will be my y-axis. Up here will be my x naught and my y naught. So x equals 0 is right here, and the problem wants us to find the final x, which is calculating from here. This is x naught coming all the way here. This will be our final x. This is what we need to find. Also, this right here is our y naught, and we're gonna call this one 0 rather than down here. So this will be 0, and we're gonna go all the way down to negative 0.950 meters. If we do it this way, it just helps us have nicer numbers and calculate easier. Okay, let's get started. Okay, this is a kinematics problem, so we're gonna rely on these formulas, and in this problem we're gonna use the one that I have marked as number 2 here. This is the one that we're gonna rely on. We're gonna use these formulas separately in the x and the y direction. First we're gonna work in the y dimension, then in the x, and then we connect between the two by using time. The two dimensions are independent of each other, so we're gonna start with one and then connect to the other one. Let's start by calculating how long it takes for the ball to fall from this height to this height. We're gonna use this one, but instead of x, we are working in the y dimension. So y equals y naught plus v of y naught times t plus 1/2. Our acceleration is g, so times g times t squared. Now our y naught is 0, our speed or velocity at y naught is 0, so all we have left, y equals 1/2 gt square. Let's solve for t and plug in. From here, t will be equal to the square root of 2y over g. Let's plug in. T equals 2 times our y value is right here, negative 0.950 meters. In the bottom, we're gonna put our gravity, which is negative 9.80 meters per second square. It says meters, just doesn't fit, but you should. There you go. Here. Up here we have meters, down here meters per second square. And if we can take a calculator, find this number, that is 0.440 seconds. Now we're gonna use this value, since time is our connector between the x and y dimensions, we're going to use this to help us calculate the x value that they're asking us to find. For this, we're going to use the same formula that we used here, but now with the x dimension. In the x direction, we do not have any kind of acceleration. Acceleration in the x direction will be 0 meters per second square. So when we write up our formula, x equals x naught plus this v of x naught times t, and as we said, no acceleration, so this term would be 0. So there's nothing else left for us to write. So that's all we're working with. Now, we have all the values that we need. Let's start plugging in. X equals x naught is 0 plus v of x naught is 6.10 meters per second times our time, and we found the time, it's right here, 0.440 seconds. And with a calculator we get x equals 2.69 meters. This is the distance that our ball goes from x naught, when it leaves the gun, all the way to the point where it hits the ground.